After a year of waiting and postponement, it is with the great pride and joy that I am able to welcome you all to your lab coat ceremony. Though we were unable to present you with your coats and celebrate the start of your journey into academic research last year, this is no way this in no way should diminish from the work and accomplishments you have achieved during your first year in the program. The lab coats received today by our students in this ceremony are representative of the steps these students have taken in their professional training. The lab coat carries with it an air of professionalism and authority, which students have the opportunity to develop and foster during the time with the program. Students receiving their coats today are a step ahead of their fellow students who have previously stood in their place, having started their training under extraordinary circumstances that still impact us today. The need for educated voices from the realm of scientific research continues to grow, and we must make sure it continues to be a part of the collective conversation to help steer and guide us in the direction we need to be headed in. When we first postponed this ceremony a year ago, we hoped to be able to soon return in person. While we are gathered today with our campus community, we hope to be able to invite our family, friends, and loved ones joining us today virtually back to campus to be able to celebrate with us in person in the near future. It is now my pleasure to introduce Dr. Eric Nestler, Dean for Academic and Scientific Affairs, Director of the Friedman Brain Institute, and Nash Family Professor in the Fishberg Department of Neuroscience. Dr. Nestler, please come forward.
Thanks so much, Dr. Filizzola. It's a great honor to welcome our second-year PhD and MD PhD students in biomedical science and neuroscience at Mount Sinai to this special lab coat ceremony. And I can say how wonderful it is personally to see you all here IRL, my favorite acronym, in real life. I also want to welcome your family and friends who unfortunately have to be with us online. Like Marta, I really look forward to a time very soon when we can all get together in person. Your class is the most affected by the COVID-19 pandemic, which is why we're holding this event now in your second year, because we couldn't meet in person a year ago. Many of you had your college graduations in spring 2020 ruined by the pandemic. I expect that many of you also had long-sought travel plans also canceled. And all of you arrived at Mount Sinai in late summer 2020, many moving to New York City for the first time, finding yourselves in Aaron Hall with severe limitations on visitors and on getting together with classmates and others, no gymnasium, and so on. Even though by summer 2020, conditions on the ground had improved enormously here at Mount Sinai, our labs had opened with full-time effort by the end of June. Your cohort had all virtual classes, lived with partial lockdowns, which made it difficult to meet with fellow students and postdocs socially. Our more senior graduate students were in a far better situation because they were already working in their labs, which provided a built-in social network and source of support. I wish that we could have been less restrictive, but were explicitly limited by federal, state, and local mandates on healthcare organizations. Let's hope that our nation and world will not see another pandemic for the rest of our lives. This one is more than enough. So here you are a year later. I trust all of you have found laboratories for your dissertation research. The start of year 2 is probably way too early for most of you to feel that your research is in a groove. That's normal. It's not often until the start of year 3, sometimes year 4, that a PhD student has an experimental system that works and generates lots of data so that real light can be seen at the end of the tunnel. I trust as well that the dark social isolation from a year ago has brightened considerably and that life is getting back to normal, or at least a new normal, still wearing masks. Your families are here on Zoom, but clawing back to normal nevertheless. So let's talk about that new normal and where we find ourselves. I am now officially post-pandemic Eric. I'm endemic Eric. COVID-19 is here, and it will not be going away. We need to learn how to live with the virus. The availability of astoundingly effective and safe vaccines developed in record time based on advances in fundamental molecular biology and virology research over the past 2 decades makes COVID-19 relatively harmless to the vast majority of us. Our experience with influenza, I think, is educational. The influenza virus is still with us 100 years after the 1918 pandemic. Despite annual vaccinations that actually began in the 1930s, and the vaccines remain far less effective than the COVID vaccines, influenza before COVID was killing on the order of 30,000, sometimes as many as 50,000 people each and every year in the United States. We need to learn how to live and thrive despite the presence of COVID. We need to get back to getting work done, back to a rewarding, enjoyable, and socializing life in the face of a virus that will be with us for some time. How do we do this? First, we need to get used to getting sick again. I think anytime a person gets a symptom of a cold or flu, they panic. But that's part of the human condition. You know that more colonial soldiers died during the American Revolution from smallpox and other viral and bacterial illnesses than from combat. And because of dramatically improved sanitation, increasingly effective antibiotics, and an astounding and ever-increasing range of effective vaccines, we are very fortunate to live in a society where the impact of infectious disease is extremely small compared to even 100 years ago. Second, we need to weigh relative risk and make decisions accordingly. In my humble opinion, IMHO, another great acronym, and why do I know? I'm a psychiatrist, neuroscientist, husband, father, and I might add, grandfather of a brand new 2-month-old baby girl. Thank you. We cannot make decisions based solely on infectious disease considerations. You know, an analogy would be to make military decisions based solely on military considerations without weighing many other risks, opportunities, and consequences. Likewise, we need to balance infection risk reduction with many other dimensions to our work and personal lives. Our goal cannot be zero infections. As I said, humans get sick. We cannot have zero risk. Life comes with unavoidable risk. After all, if we wanted zero risk in life, we should have 5-mile-per-hour speed limits on highways. Our nation tolerates 50,000 motor vehicle deaths each year because of the advantages that come with faster travel. I am very proud that we've been able to achieve at Mount Sinai a good balance within the constraints placed upon us by government agencies. We opened our labs faster and to a greater extent than any other medical center in the United States, which minimized the disruption to our students' and postdocs' careers. And we did so safely. We have had 0 cases of COVID-19 contracted in our labs over the past 18 months. I'm going to repeat that. We have had 0 cases of COVID-19 contracted in our labs over the past 18 months. A small fraction of our faculty, trainees, and staff have tested positive, like our relatives and friends, but contract tracing revealed that 100% of those cases were contracted off campus, typically in social activities on evenings or weekends as life went on. We got this big decision right. Now, our faculty, trainees, and staff with young children need to exercise additional precautions. This should be eased as vaccines are introduced for younger and younger children, and we're hoping that children at 5 and older will be approved soon. We know that some of our colleagues are immunocompromised and cannot be vaccinated for medical reasons, and we need to ensure that those people are protected and offer special dispensation so that they can get their work done safely too. And there are still real struggles about traveling to see family, especially overseas, not to mention the mental health toll of 18 months of social and, for many, economic deprivation. But despite these challenges, let's all fight back. Let's get back to the labs in person, back to in-person lab meetings, in-person WIPs, in-person research seminars, and in-person conferences. Zoom is better than nothing, but it doesn't come close to doing things IRL, especially when we have our cameras off. And we received good news today about international travel, another sign of things slowly getting back to normal. I have always considered myself one of the luckiest guys alive because every day I love going to work where I get to run a lab, work with young people like yourselves, and pursue science, my life's passion. I hope that each and every one of you use your PhDs for an equally rewarding and enjoyable career. Thank you.
Thank you, Dr. Nestler. I would also like to recognize and thank our alumni supporters who contributed to making this very special ceremony possible. Our deep appreciation also goes to the Mount Sinai Alumni Association for sponsoring the lab coats our students are about to receive. I invite Dr. Alexis Colvin, Associate Dean for Alumni Affairs, to join us on stage. Dr. Colvin.
Thanks and good afternoon. Although we have been physically distant, the past year has also brought the Mount Sinai alumni community closer. You've not just entered graduate school, but you've also joined a family of incredible alums from all over the world. I hope you have and continue to take advantage of all of the opportunities to learn from them. For instance, our Alumni Connect mentorship program pairs alums with current graduate students and has nearly doubled in size over the past year. There are also weekly Alumni Connect small group meetings in which students meet virtually with a diverse range of alums to discuss their career paths and benefit from the wisdom of their experience. These sessions are truly invaluable. Before I close, I would just like to say how honored I am to be able to welcome you at the beginning of your grad school journey and to let you know that I will also be here at the end to welcome you into our alumni community. Congratulations and best of luck.
Thank you, Dr. Colvin, for those words, and a big thank you again to our alumni community. It is now my pleasure to introduce Dr. Ravi Iyengar, Director of the Mount Sinai Institute for Systems Biomedicine, and the Dorothy and Louis Rosenthal Professor of Pharmacological Sciences. Dr. Iyengar will introduce our keynote speaker. Dr. Iyengar, please come forward.
It's my pleasure to introduce Padmini Rangamani. She's there, good. She's a tenured professor of mechanical and aerospace engineering at the Jacobs School of Engineering at UCSD. She was my graduate student here at Sinai and graduated in 2010. Her thesis focused on understanding, she's a mechanical engineer by training. Her thesis focused on understanding how mechanical forces control cell shape to regulate biochemical signaling and how cells get organized within tissues. The thesis study was published in Cell in 2013. It took a couple of years of revision to actually get it in. But The nice thing was in 2014, when it was their 40th anniversary, they polled a number of scientists around the world, and her paper was chosen as one of the top papers over the years that Cell had published. So she had a very good start. She has now set up a very well-recognized research program studying how biomechanical signals regulate physiologic functions in a number of cell types. She's received many honors and, of course, grants during this past decade. And this includes the Presidential Early Career Award for scientists and engineers, the highest honor that the US government bequeaths on outstanding scientists and engineers beginning their independent research careers. In addition to her sort of successes in research, she has also been an outstanding mentor. And this year, she's one of 2 people in the whole UCSD campus who has received the Chancellor Awards for exceptional postdoctoral mentoring. I think she's an outstanding example of the kind of rigorous training that's available at Mount Sinai, and I'm sure all of you will avail and benefit from it. It's my pleasure to invite Padmini to give her keynote address.
Thanks, Ravi, for that kind introduction. Let me begin by thanking Deans Filizzola and Nestler for the invitation to be here virtually. I, like many of us, I'm waiting for the vaccination for a 11-year-old, which is why I'm not traveling. It is a pleasure to participate in this lab coat ceremony, which is an important milestone in your relatively short PhD journey and your long journey as a scientist. And so when I was invited to speak to all of you, I had a chance to reflect upon my own journey. I'm marking 20 years since I left India to come to the US for grad school this year. And so what I'm really going to share with you in the next few minutes are what I wish my younger self had known. It is very important to remember that obtaining a PhD or an MD PhD is essentially a lifelong commitment to the service of science, right, and to humanity. In that sense, when many of your college classmates went off to get jobs and, you know, the 2.5 kids and the picket fence, you chose this absolute privilege to build a career out of curiosity and discovery. And when we do this, it's a very conscious decision not to spend just the 5 years or so learning to be a scientist, but also recognizing that it's a choice we make every day. And so when you walk into the lab, when you get to do those experiments, you are enjoying the privilege of following that curiosity. But then when that is such a romantic notion that science should be all these beautiful, amazing things and every experiment should work, the reality is that one has to be very strategic about how to go about science because you don't have coursework, you don't have a syllabus, and sometimes you just don't know what to do. So in what I'm sharing with you, I think there are glimpses of quite a bit of what to do, but maybe some of what not to do. And much of this is very granular, right? It's literally like a strategic plan, if you will, and I hope you'll find it useful. So I'll tell you a little bit of my own story on how I came upon Mount Sinai. I have actually, as Ravi mentioned, my background is actually in engineering. And I was working on my master's in chemical engineering at Georgia Tech, where I was working on tissue engineering. Now, the thing with tissue engineering is that I'm only half joking when, you know, a lot of it was done like it's a baking recipe, right? If you put polymer and if you put cells and all of that, at least that's how I was exposed to it. And the tissue just wouldn't grow in the incubator. And I found myself culturing primary cells with absolutely no biology background. And so when life happened to me and I came upon the opportunity to pursue a PhD, I decided I was going to do it in biology because I really wanted to do biology. The further anecdote to this is that when I was in high school in India a very long time ago now, you had to choose between a math track and a biology track. And I really, really hated having to choose one over the other. So I kind of felt like this was a do-over. So I could really go learn biology and figure out what these cells were about. And so I landed here. I must say that the admissions office presumably knew none of my letter writers, and somehow the grad school took a chance on me, and I'm ever so grateful. And so with that formal journey in biomedical sciences beginning, it was also around the time that biology was more openly quantitative, and the explosion of systems biology served me really well. Ravi has always been at the forefront of interdisciplinary fields. I knew the math and the physics, and I was very fortunate to find such a rich program of research that allowed people like me who had a mathematical background to work in biology. Even today, my most favorite thing to do is to draw signal transduction pathways, much to the chagrin of my mechanical engineering graduate students. My point is that I followed my curiosity. The storyline reads very romantic, and it's all great, it all worked out, but that's not the entire story, right? The entire story is that there are people. There are people who played such crucial roles in enabling this to become a realization. So what advice can I give you? In thinking about a lot of what I wanted to share with you, much of it essentially came down to good practice and good discipline so that your scientific careers can fully realize your potential. First and foremost, people. Exceptional biomedical science is about exceptional biomedical scientists. I would strongly recommend that you seek and surround yourself with people who invigorate your thinking, who challenge you to question your assumptions, who push you to the edges of comfort, and then who will always have your back. Now, when I say this, it is easy to interpret this message as I just need to be around exceptional scientists and everything else will be okay. It is also important to recognize that kindness and decency and scientific genius are not mutually exclusive traits. You must surround yourself with people who bring out the best on all fronts. It is completely possible to disagree and be polite at the same time. You can uphold integrity and standards while extending grace and kindness. This ultimately is what will shape your approach to research and path-breaking discoveries. And in that spirit, your choice of a research lab, your thesis advisor, your thesis committee are all more important perhaps than the particular project itself. Listen to your peers, interview the PIs while doing your rotations, trust your instincts. More often than not, we all like to believe that a particular situation, it won't happen to us, only to find out later that you can't fit a square peg into a round hole. So who's the square peg? Who's the round hole? How do you know? A lot of this comes down to self-awareness. Your self-awareness is key. What kind of mentoring do you like? Do you like a weekly check-in, a daily check-in? Do you like somebody to micromanage your time? Or do you like to be left alone and I'll give you the first draft of the paper? In my own PhD work with Ravi, I have kind of transitioned across all of these. And I think it is a lot to Ravi's benefit that he kind of knew when to leave me alone and when to, be in my face. And I didn't recognize that at that time because I didn't know better. I think it's important for you to know what you want at different stages, and it changes. Do you want a formal mentoring? Do you want informal? What about peer mentoring? Writing groups, journal clubs, these are all these important, intangible aspects of scientific research that can really help support you and guide you. The community of the lab is actually a very important thing. While looking for labs to do my postdoc at UC Berkeley, I chose to not join a particularly attractive research program where the PI was a up-and-coming rock star scientist. That's how the campus knew him, because of a very simple reason, which was that all the group members went to happy hour with their PI at 6 p.m. most days. I went to pick up the baby from daycare. This by itself is not a reason enough not to join a lab, but a lot of scientific discussions happen over these casual social engagements, and I would be conspicuous from my absence, and that would not necessarily allow me to be creative in the best way possible. I ended up in another group, completely different flavor, smaller, perhaps not as glamorous, and I thrived there. The PI also left at 4:30 p.m. every day to pick up his daughter, and it was the right environment for me at that time. The pace was slower, I took my time to learn a new research area, and it worked out very well for me in the end. So the big challenge when you're still developing the self-awareness is to figure out what you need to do to succeed. And sometimes it is very important to recognize that it is your career, it is your PhD. Your PI already has one. You are in charge here, and when you take that control, amazing things can happen. On communication, it is very important to recognize that your PI probably appreciates it much more than you can recognize when you go to them with questions or seeking help on specific topics, or if you wish to discuss career plans. Usually when my students don't say anything to me, I assume everything is fine. I cannot fathom if someone's struggling. So communication is key. And again, figuring out whether you want weekly updates, written reports, group meeting presentations, are all various aspects of this communication. I have to share this little story. I don't know if Ravi remembers this or not, but I used to always wonder, but I already told Ravi this, I'm going on vacation, or I already did this calculation. And the strange thing is, because karma kind of gets you in this very same lifetime, in my case, within a decade, my students tell me this all the time. I already wrote you an email. I already told you on Slack. I already did this. This is not doable. So it's the strangest thing. It's because our minds can sometimes get very easily distracted by the other things we are doing, that it's important for you to communicate and, keep us on our toes, remind us what we need. Things like needing a letter of recommendation, a nomination. Give your PI enough time so that they can get it done without having to stay up the night before. And the more you communicate early, communicate often, the more you'll get out of this relationship. Now, I know we are in a biomedical sciences institution, but I also encourage all of you to think about your career goals. Is it academia? Is it industry? Is it research? Is it policy? It's your career. You should be thinking about it and seek advice on how you might realize that. Yes, during your PhD, you have to make new discoveries and you have to publish your papers, but what happens after? And so you can take charge of a lot of these things. Kind of comes down to the brass tacks then, right? What else do I have to say about this? Read a lot of papers, read reviews, and then chase down the original finding. If looking for a particular experimental protocol, go back all the way down to the original paper. And then while reading, find a good way of taking notes. This seems so mundane that you might be wondering, why is a keynote speaker telling me to take notes? I promise you, it'll be so useful when you summarize that paper and then you're writing your own, that all you need to do is go grab that little précis you wrote and stick it in there. Participate in journal clubs, ask seminar speakers questions. It doesn't matter if you are nervous, just, ask one small question and then you will ask the next question. It makes a big difference in just trying to learning how to speak up. Well, if you're reading a lot, something we often don't do early enough is writing a lot. And I'm going to basically say something that's probably not a popular opinion, which is that writing need not wait until all the research is done, all your figures are laid out and beautiful and perfect, and you have your sample size so you can get everything going. Writing is active research and thinking. The more you write, the more you have to think about what you're doing and why you're doing it. You can use those notes you made from the reading to draft an introduction. What is the gap in the field? Why are you doing this particular experiment? Why is that the most logical experiment to do? In a way, it helps you justify your actions. And writing doesn't have to be tedious, doesn't have to be onerous, doesn't have to be sophisticated or elegant or your GRE word list, although I don't think people take GREs anymore. It doesn't have to be very difficult. It can be bullet points. The goal when you write is to strive to have the answer to this one question be yes. Can the reader understand the point of what you've written without having to talk to you? This is a learned habit. You can form a writing group, 30 minutes each day. You can do this. The other thing I wish I had known much earlier, given just how much I write all the time, is making figures, just making schematics. Trying to communicate this complex idea of mechanics in cells with actin and microtubule and the membrane changing its shape and whatnot and making figures. Humans are visual creatures, and figures should be able to tell the story. They don't have to be pretty in the beginning. They can be doodles. Make the figures, label the axes, make sure you have units, small but important things. You know, they'll make a world of difference in the quality of managing your frustration as you go through the research process. Learn to code. Even if you don't think you will ever code, learn to code. You can automate your scripts for plots. You can automate your image analysis. And there are many online courses where you can learn to code. And you are in an era of biology where biology is the generator of big data, and big data needs coding. So if there's one skill that seems as a big aside in biomedical sciences, I would say learn to code. Learn in the same spirit as writing, in the same spirit as reading. Use your group meeting presentations to make good talks. I can guarantee you, if you make the talk the night before, your audience will know it. So take the time, prepare your slides, explain every plot. I know this sounds like so granular, but if you have a plot up there, you have to explain it. And hey, Zoom advantage, you can video your own talk, record it, and see how it sounds, and then practice on it, right? So you don't need to call your friends to say, hey, I want to give a practice talk. You can listen to it yourself. So, small advantages of Zoom. So these are all the sort of granular things you can do. But then if you take a step back and you look at this 5-year journey, the strangest thing is finding the way to lift oneself up when the research process inherently sets you up with more setbacks than flashes of insights. I know there are families on this call. I know many of you will go home for Thanksgiving and Christmas, and there will be cousins who got a raise, and everybody's doing amazingly well. In my own case, people turn to me and say, so have you finished school yet? Oh, no, I got this amazing result that I'm going to put in this paper, and my advisor says it's going to go to Cell. Oh, so you're still in school, right? So you're living in this little bubble that is so different. So you strong, and then it can become this thing known as imposter syndrome. So I think if you add that peer-to-peer comparison, then it's easy to ask, you become vulnerable. It's easy to ask this question, do I belong? And so finding mentors outside of your PI who can lift you up, who can guide you through this is very important. Remember, no one mentor can do everything. Sometimes the PI just has to focus on the scientific aspects. So find your mentors, right? So when I was at Sinai, Professors Terry Krolwich and Maria Diverse Pierluisi were the people I would just go talk to and be like, this thing is not working. I don't know what I'm modeling. And they would, listen to me for 30 minutes and give me some advice. And then I would go back and try again. And you can also have peer mentors, right? Your lab mates or many of you classmates, you can have peer mentors, and it can be even outside the institution, but if possible, don't let the imposter syndrome get to you. The most critical feature for longevity in a scientific career is perseverance and resilience. You're not necessarily born with it. Those are learned skills that you can have. And as we talk so much about what it takes to do science and to be a scientist, it is also important to remember that you live in one of the most vibrant cities in the world. When I was young and I was cool, I lived in Manhattan, and you're a stone's throw away from Central Park. Make the time to get out, take a walk, exercise in muddle through the data that seems to make no sense. Make sure to give yourself that time, and you'll be amazed at how small breaks can rejuvenate your thinking and provide clarity where you might have just struggled for like hours on end. And finally, I will leave you with this. We are all biased. It is human nature. It is important to recognize that we all have it and we work actively against it. If you won't say something to a man, don't say it to a woman. Don't expect that it's okay to make assumptions in terms of anything, appearance, sexual orientation, gender, ethnicity, race, religion. Be kind, extend grace. Apologize if you make a mistake, and don't make the same mistake twice. If you see biased behavior, speak up. A silent bystander is as bad as a perpetrator. Like they say in the New York City subway, if you see something, say something. Be that person. Be respectful of others and be respectful of yourself. Being right and being kind are not mutually exclusive. And now, I wish you the very best of success, and I hope you put on your lab coats, go forth and conquer the world. Thank you very much.
Thank you, Dr. Rangamani. I hope your words today act as an inspiration to our students as they continue on their academic journey. Next part of this ceremony, the part you have been waiting for quite some time, will be the presentation of the PhD and the MD PhD students who started their career for fall of 2020, with the lab coats as a symbolic representation of their rigorous academic scientific training. The students will receive their lab coat from distinguished members of the graduate school faculty who exemplify outstanding graduate teaching and mentoring. It is my pleasure to introduce some of our directors of our multidisciplinary training areas who will be coaching our PhD and MD PhD students who began their research in 2020. Please stand as I call your name. Dr. George Handley, Director of the Neuroscience Program. Co-Director of Cancer Biology MTA, Dr. Doris Germain. Co-Directors of Development Regeneration Stem Cells MTA, Dr. Florence Marlowe and Dr. Robert Krause. Co-Directors of the Genetics and Genomic Sciences MTA, Dr. Laura Huckins and Dr. Jonathan Carr. Co-Directors of the Immunology MTA, Dr. Jeremiah Faith and Dr. Konstantina Alexandropoulos. Co-Director of Microbiology MTA, Dr. Jim Lim and Dr. Domenico Tortorella. Co-Director of Pharmacology and Therapeutics Discovery MTA, Dr. Eric Sobi. And our newest Co-Director for Artificial Intelligence and Emerging Technology MTA, Dr. Ait Greenspan. It's also my pleasure to introduce this year's roster reader for our doctoral students, Dr. Matthew O'Connell, Senior Associate Dean for Curriculum, Recruitment and Admissions for the Graduate School of Biomedical Sciences and Professor of Oncological Sciences. Dr. O'Connell.
Well, thank you, Dean Filizola, and finally, it's my pleasure to welcome you all here to our PhD and MD PhD classes, and to your family and friends and supporters who are live streaming this. I'm sure you're as proud of these guys as we are. It's truly an honor to be a part of this special ceremony. I ask for those in the audience if you could just hold your applause until we quote a group of 4, and then they'll stand to have their picture taken. I will be reading each student's preferred name, which may differ from the name in the program. Okay. And so it's now my pleasure to call up the 2020 PhD students. think you can sort of keep going. Yeah. Okay. Wait for it. Wait for it. Okay. The first student is Faith Adams. Faith Adams. Gabrielle Altman, Elisa Arcechi, and Christina Atanasov. Photo formation. Okay, continuing on. Erica Barrell, Luca Brambilla, Emily Bramall, and Megan Branch. Okay, continuing on. Yonina Bikoff, Lauren Chang, Eva Shebashev, and Anisha Cook. Okay, Julia Crossio, Winston Cuddleston, Ashley Cunningham. 3 for this one. Alba. Okay, Federico DiTullio, Lauren Dierdorf, Tasneem Ibrahim, and Alexandra Fink. Excellent. So continuing on, Trayvon Giles, Alba Esclara Marino, okay, and Emma Hayes. Excellent. Okay, Pushkala Jayaraman, Emily Kozik, Carice Lansico, and Veronica Lennon. And so thank you to our first 4 quoters. Thank you very much. Taking a step to the right. Could the next 4 please join us on stage? Okay, away we go. Anina Lund, Delma Mashaka, Jaime Matthias Tick, and Sam McConnell. Okay, Alexander Munch, Alexandra, Hong Ha Nguyen, Mahak Ningu, and Sarah Philippi. Okay, continuing on. Paul Phillipsburg, Ashley Reed, Michaela Rosen, and Christos Sazidis. Okay, let's see how we go. I'm getting a few hand signals here. Ivan Sola. Oh, that was there we go. David Stein. Just 2 on this one. Let me see. Perna Suri, Karen Terrian, and Abhishek Vaidya. And our final group for the PhD students, Sarah Williams, Miranda Wilson, Janice Yang, and Yi Zhong. So thank you, coaches, and to all of our PhD students, my heartiest congratulations.
It is now the time to call on stage the MD PhD students who also started their research last year. Dr. Margaret Barron, Senior Associate Dean for MD PhD Education, and Dr. Talia Schwartz, Associate Dean for MD PhD Education, will read the names of the MD PhD candidates. Dr. Barron and Schwartz, please come forward.
We will call MD PhD students beginning their research in groups of 4. I kindly ask those of you in the audience to hold your applause until the group of 4 is complete. Will the following students in attendance today please come up? Oh. Will the following students in attendance today please come up to the stage when we call your names? Brandon Dale,
Annalisa Jones,
Matthew Lynn,
Om Patel.
Michelle Tran,
Nicole Zatorsky.
thank you to the coders.
Now I have the pleasure to present Dr. Basil Hans, Senior Associate Dean for Student Affairs and Associate Dean of Wellness, to administer the PhD oath followed by the faculty pledge.
All right, thank you, Marta, very much. I think this actually, as I get settled, would be a great time for everyone who got their coat today to stand up, look into this camera right here, and give all of your family, friends, and loved ones a very loud thank you for the work that they've done to help you get to this point. Great, thanks. Stay standing because you're going to have to stand up in just a second anyways. But I definitely want to add my congratulations. This is really an excellent day, a year later than all of us would like to have had it, but a great day nonetheless. So congratulations. Welcome to the Sinai family. Before I begin reading the oath, I would like to invite all of our PhD doctoral candidates and all of the PhD faculty and staff in the audience and on the stage behind me to stand, so that we can all recite the oath and dedicate ourselves and rededicate ourselves to the commitment of our profession. So the oath is printed on page 8. It's also on here on the screen, so if you would. With my Doctor of Philosophy, I willingly pledge to uphold the highest levels of integrity, professionalism, scholarship, and honor. I will conduct my research and professional endeavors with honesty and objectivity. I will apply the highest standard of great generation and application of knowledge, and fully acknowledge the contribution of others. I will not allow financial gain or ambition to cloud my judgment or decision-making, nor cause harm to society or subjects of research. I will embark on the furthering of knowledge through respectful interaction and collaboration with my colleagues and community, without prejudice or exclusion. I will be a role model and use my skills to inspire, mentor, and empower future generations, instilling in them the highest principles of ethical behavior. As witnessed by all present today, in the tradition of graduates before me, I do affirm to uphold these guiding principles. Everyone, you can be seated. And now I ask all faculty members of the Icahn School of Medicine at Mount Sinai to stand and join me in the faculty pledge, which can be found on page 9 and will also be on the screen as soon as I advance the slide. There we go. As teachers and mentors for our students, We pledge to maintain the highest professional standards in all of our interactions with students, patients, colleagues, and staff. We pledge our utmost effort to ensure that all components of the educational program for students will be of the highest quality. We will respect all students as individuals without regard for gender, race, national origin, religion, or sexual orientation. We will not tolerate anyone who manifests disrespect or who expresses biased attitudes towards any student. We will not tolerate any abuse or exploitation of students. In an effort to nurture personal development, we pledge that students will have adequate time for reflection, as well as personal and family obligations. In nurturing both the intellectual and professional development of our students, we will celebrate achievement of academic excellence and demonstration of the highest virtues of our profession.
Thank you. I would like to thank the Graduate School of Biomedical Sciences staff for their assistance today, and again the Mount Sinai Alumni Association for their ongoing support. In particular, I would like to recognize the following individuals: Brad Gano, Associate Dean for Graduate School Administration, and his team, Matt Cipriano, Tiffany Cody, and Sahara Bryant. Without their dedication and hard work, the ceremony would not have been possible. All present. All present are invited to attend the reception in our hall courtyard across the street. Please remain seated until those on stage have exited the auditorium. I will also ask the 2020 matriculating PhD and MD PhD classes to remain seated for group photos. The lab course ceremony of the Graduate School of Biomedical Sciences at Mount Sinai is now concluded. Thank you and congratulations to all.